Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem without a calculator. And make sure to stay until the end of the video where I have a bonus problem that is similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of 19 minus 2 to the power of 18. Now to start, 19, this is equal to 18 plus 1. So now if I replace 18 plus 1 with 19, I get 2 to the power of 18 plus 1 minus 2 to the power of 18. Now, an important property of exponents is that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So this actually technically distributes. So in this case, a would be 2, m would be 18, and n would be 1. So now I have 2 to the power of 18 times 2 to the power of 1, and I still have my minus 2 to the power of 18. Now what I'm going to do is I'm going to factor out 2 to the power of 18. So now I have 2 to the power of 18 times, now 2 to the power of 18 times 2 to the power of 1 divided by 2 to the power of 18. Well, these two would cancel out, so I would simply just be left with 2 to the power of 1. Now I have this minus 2 to the power of 18 divided by 2 to the power of 18 is simply just 1. Now 2 to the power of 1, this is the same as simply just 2, so I have 2 minus 1, and 2 minus 1 is 1, so I have 2 to the power of 18 times 1, which is equal to 2 to the power of 18. Now, 2 to the power of 18, this is the same thing as 2 to the power of 9 times 2, because 18, this is equal to 9 times 2. And now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. And the same thing goes vice versa. If I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So in this case, 2 to the power of 9 times 2, we can think of this as a to the power of m times n. So now I'm going to be putting this in the form a to the power of m to the power of n. In this case, a is equal to 2, m is equal to 9, and n is equal to 2. So this would be 2 to the power of 9 to the power of 2. So now 2 to the power of 9 to the power of 2. Well, let's first solve 2 to the power of 9. Now, we're going to ignore the exponent for now. So 2 to the power of 9. Now, remember, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 9, this is going to equal 2 to the power of 3 times 3, which is equal to 2 to the power of 3 to the power of 3. Now 2 to the power of 3 to the power of 3, well, first off, 2 to the power of 3, this is equal to 8. So now I have 8 to the power of 3, which is equal to 8 times 8 times 8, which is equal to 64 times 8, which is equal to 512. So 512 is our value for 2 to the power of 9. So now we have our squared. So now we have 512 squared. Now 512 squared, how would we solve this? Well, 512, this is the same thing as 500 plus 12. So this would be the same thing. If I substitute in 500 plus 12 for 512, I get 512 is equal to 500 plus 12 squared. So I have 500 plus 12 squared. And now if I have something in the form a plus b squared, this is simply equal to a plus b times a plus b. So 500 plus 12 squared, this would equal 500 plus 12 times 500 plus 12. Now to solve this, we are going to multiply and we're going to distribute. So let's first start with 12. We're going to do 12 times 500 plus 12 times 12. And then with 500, I'm going to do 500 times 500 plus 500 times 12. So 12 times 500, so I get 12 times 500 plus 12 times 12 plus 500 times 500 plus 12 times 12 again. Now this is equal to 12 times 500, that is going to equal 6,000, plus 12 times 12, that is going to equal 144. Now, plus, I made a mistake, sorry. This is not 12 times 12, this is 500 times 12. So now plus 500 times 500, which is going to be 25 with 4 zeros. Plus finally 500 times 12, which is again 6,000. Now we're going to add these up. 6,000 plus 6,000 is 12,000. Plus 144 plus 25 with 4 zeros, which is 250,000. Now 12,000 plus 250,000 is 262,000 plus 144, and this is equal to 262,144, meaning 2 to the power of 19 minus 2 to the power of 18 is equal to 262,144. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have 6 to the power of 100 minus 6 to the power of 99. Now, I'm actually going to rewrite 100 here as 1 plus 99. So now I have 6 to the power of 1 plus 99 minus 6 to the power of 99. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 6 to the power of 1 plus 99, this is going to equal, let's think of 6 as a, 1 as m, and 99 as n. This is going to equal a to the power of m, so 6 to the power of 1 times a to the power of n, so 6 to the power of 99. And we're subtracting this with 6 to the power of 99. Now, because both the terms here, 6 to the power of 1 times 6 to the power of 99, and as well as negative 6 to the power of 99, both of these terms have 6 to the power of 99 in them. So I'm actually going to factor out 6 to the power of 99. So now I have 6 to the power of 99 times 6 to the power of 1 times 6 to the power of 99 divided by 6 to the power of 99, simply just 6 to the power of 1 minus, now 6 to the power of 99 divided by 6 to the power of 99 is 1. So now 6 to the power of 1, which is simply just 6, minus 1, times 6 to the power of 99. Now let's solve what's in the parentheses. 6 minus 1 is simply 5. So we have 6 to the power of 99 times 5. And this is the most we can actually simplify this. So this is our answer.